Submit. All right. Welcome, friends. Thank you for waiting. For those of you who were on time, thank you to those of you who made it, even if late. I'm Alex Noon, data scientist, background in hospitality and training. Let's call it that. I basically did my capstone on decoding the digital divide, basically looking to analyze how the digital divide impacts student educational outcomes. So I'm sure everyone has seen this image. Yeah. It's at a Taco Bell. It is a couple students on their devices using the Wi-Fi at Taco Bell. Basically, the point here is that Taco Bell, or Starbucks, as Jeb Bush says here, is not a social safety net. People should not have to, find the nearest available wireless network in order to participate in their education. So my goal here was to look at how that's impacting assessment outcomes and impacting educational assessments. So the goal was to predict the impact of the digital divide on the public school district educational outcomes in the United States. So a quick overview of what we're about to go through. The CRISP-DM process is a cross-industry standard process for data mining. It's jargon. I just like to have it up there because it looks nice, it looks fancy. Briefly, we'll go through business understanding, which is just understanding why we're studying this, what the digital divide is, and how we assess educational outcomes. Then we're going to look at what data we have available to analyze that. We're going to go into some exploratory analysis on that data, make some quick observations so we can build a predictive model that will tell us, that will be able to predict educational outcomes. And from that, we'll extrapolate some feature importances and make some conclusions based on that information. So within the business understanding, we'll just go through these three things. Basically, the virus is forced virtual learning, requires internet and device access, which not all students have, and negatively impacts their outcomes. So this map here just shows really briefly in blue, schools who are only opening remote; in yellow, schools who are opening in a hybrid form; and schools that are opening in red in full person. The basic idea behind this map is that if you're in any of these blue areas and you don't have internet, you're not being educated, bottom line. So how do we define digital divide? It's two things. It's broadband access, and this is a map of households that have or don't have broadband access. And then we also define it by device access. So do you have a computer to access this information or not? As for the academic assessment part, we look at proficiency in math and proficiency in reading and language arts. I created a composite proficiency just to make it easier to create a predictive model. We'll look at that later. So now we're going further into the data. So basically for that digital divide part, we have census data. And for the educational outcomes, we have data from the Department of Education. The reason I chose these two data sets were that they all went down to district level. So a lot of places will analyze things by county or by census tract, by a million different ways, but not all data sets go down to the school district level, which is how funding is decided. So what we used from the census was what's called the American Community Survey. It's not part of the census itself, but it's done more frequently. Basically, it's a sample population survey. They extrapolate what the broader population should look like from that information. And they ask a whole bunch more questions other than the census. The census you can complete in 2 minutes. This is a much longer, bigger survey. They have questions related to social characteristics, economic characteristics, and all that fun stuff. But from that, we chose their access to device and access to broadband internet as our I guess looked at features. I also chose 8 more features. Chose 8 more features based on what I thought their impact would be upon educational outcomes, what I thought would be the most powerful ones. For education, we looked at the Department of Education's EdFacts annual state assessment. Basically, states give out assessments every year to gauge proficiency in math and reading and language arts. And then the Department of Education aggregates this. They performance map it by some standard that I can go into later if you'd like. And then they output this. And it's aggregated by district. So we have about 13,000 districts in the US. As you can probably guess from the previous mentions, the limitations to this data is that the census is a sample, obviously. So there's range of estimates in that. from that, I only used all households. You can go further into households that only have a certain age of children, but I just wanted to get a general picture for this project. And then I cherry picked my features. Obviously, whenever you cherry pick stuff, there's always stuff being left out. Ask me about that later if you'd like. And then from the education side, we looked at, it's outdated. I mean, it's from 2018. 2018 is not very recent in technology. That's almost a decade ago. The other thing is that it's public schools only. So I grew up in private school, so my education not be included in that. And then it's state defined proficiencies. So it is performance mapped, but it's defined by the state. It's up to the state to say who is proficient or not, which obviously can have its own biases in it. Marisa told me to get rid of this part, but I made a lot of cute animations and I wanted to keep them. So I'll go through it very briefly. In this exploratory data analysis area, we just look at a few issues that I had with the data and how I solved them. So a lot of it's privacy protected. In regions in the educational data set, information that was privacy protected, they would have things like GE80, which means greater than or equal to 80% proficient. For those, I just created a composite or an average of 90, just said 90%. Some of them I eliminated because they were too big, right? Like greater than or equal to 50% proficient is not very informative. So I eliminated some of them. I estimated some of them. Skewed feature distributions, this is just going to impact how the model turns out, how effective it is in predicting. So I just normalized them, as we can see here. It looks not a lot better. Feature correlation. Normally, we wouldn't want any of the red spots here or the dark blue spots, because that would mean the features are correlated, and it's not going to be good for some machine learning models. But I kept them because I only started with 10 features in the first place. So to be eliminating features at that point would just be down to like 4 or 5. Target correlation. Basically, it's same thing, right? You don't want to. Some of the models don't perform well if the targets aren't correlated. I just basically created a composite feature. Also makes it easier to just predict one target than 2, I guess. And then missing data. As you can see, this map is not complete. That was my data set. I was so proud of myself for being able to map it. And I looked at it and was like, wow, what the hell? You can see New Mexico is missing some data. There's a lot of stuff in California that's missing. Virginia also missing. For various regions. Basically, I started with secondary school districts. So I added all districts in at this point. And then I also went back a year for New Mexico and Virginia. And even still looking at this, I looked at it earlier today and realized I was missing data from Maryland. And that looks like, I can't tell if it's like Connecticut or parts of New York, but there's still data missing, but just a couple of solutions right now. Now, predictive analysis. This is the juice. So this is why we did this, right? So predicting educational outcomes, it's not just about predicting the outcome, but it's also about figuring out how important those digital device access and broadband access features are in making those predictions, right? So I chose to do regression techniques. So this is just a baseline overview of this. So started with linear regression, just to get like a baseline and gauge how well my model was performing. Moved on to a decision tree, which basically, if you imagine like an organizational chart and replace the like titles or departments or positions with features like digital access and poverty ratio, that's a decision tree, upside down. And then I moved on to a random forest to see if that would perform any better. Didn't perform that much better, so I kept going and got into a gradient boosted tree, which basically improved the performance to what you see is 0.5132. That's the adjusted R squared, which basically measures the improvement in predicting that my model has over just taking the mean of the data that I have. And just one more way to just look at that is theoretically, we would want. You can see the original values on the bottom on the x-axis and my predicted values on the y-axis. And theoretically, we'd want everything to be on that diagonal line. It's not all on that diagonal line, as you can see that black line, but it's pretty close. And the important thing to notice here is that it's 10 features that I just cherry picked to make these predictions. So for 13,000 school districts, these 10 features going into this model made it this much more accurate. So here are the two there's a couple things you notice. The first thing, obviously, poverty ratio is the most important factor in determining assessment scores, right? That I was kind of not surprised by because I saw it in the original data as I was just doing exploratory analysis. But then we also notice percentage of broadband access is the third most important feature in predicting these values. And then the last thing that I noticed was percent device access wasn't as important. In previous models that I was looking at, it was, it was paired with broadband access. They would both be at the bottom or in the middle. But it's clear that it's not as important in broadband as broadband access and making these predictions. So I'm going to enable questions here. If you have anything that's on your mind, feel free to throw them in there, but then I'm going to go through these concluding here. So recommendations. At Georgetown, those of you Hoyas out there, Hoya Saxa, first of all, but second of all, you're familiar with cura personalis. That means taking care of the whole person. So read one quote that was the most telling for me from Minnesota's Public Radio News. It says, "You're not going to set up a child for internet for school in a home that has no electricity," right? So you can't ignore the extent of the impact that the poverty ratio had upon those outcomes if you're seeking to improve those outcomes. Granted, providing a whole bunch of devices and hotspots is a lot easier to solve than solving poverty, and it's more tangible and direct, more directly actionable, but you can't ignore that. And if you want the biggest impact, that's what you'll look at. But after that, well, you could look at, if you do want to look at those things, you look at broadband access over device access. People just need, if you think about that original image in the Taco Bell, it's like those students had the devices, they just needed the internet to get access to. So that's obviously what you want to focus on more. You can still, obviously, a lot of people don't have devices, and that's still going to impact it. But if you're looking to allocate resources that are limited, focus on broadband. And I just listed here a couple things. SpaceX just a couple days ago announced they're launching some satellites into low Earth broadband or broadcast, whatever they're calling it, fancy stuff. And then my last big suggestion is just get creative about educational solutions. It's kind of odd to see that all those schools in blue that are just opening remote only, right? If you know that there's a digital divide and you're going into that opening remote only, you're obviously excluding a lot of people from the get-go. So just getting more creative in things like just doing it, considering analog solutions. I remember when I was in choir school in 5th grade, if we were going on a tour, we had to take tour packets with us when everyone else was being educated in person, right? That's something you could theoretically hand out with, when they're handing out those federal lunches, right? Just being more creative about how we think about that stuff. In Europe, they use TV and radio. And actually recently, just today, I read an article about somebody doing what's called data casting. They're using federal emergency, waves to broadcast internet. Basically what firefighters and ambulances use to talk. They're starting to use that to put out education. So being more creative about how we come up with these things, how we bridge that broadband gap, and how we give people device access. And lastly, additional areas for analysis. Obviously, as I stated before, we can increase the detail and the granularity with which we analyze certain things like digital access. Is a computer as effective in delivering education as a smartphone? Is an iPad better than a smartphone? Things like that. Also adding geographic features in there, looking at that rural-urban divide. I only took 10 targets or 10 features from the census. You should obviously take more. That's every data scientist's dream, is to get more data. So obviously doing that. And looking at the target, just separating the predictions by subject. So looking at exactly how the predictions come out for math or reading and language arts. And then lastly, improving the model. So updating it with more data, like I said, and then also using just time series analysis. So I think the tough thing with this data is that it's on the EdFacts website as new and recent, but it's from 2018. And that's just not going to cut it in this day and age. We need to be able to act quicker on that kind of stuff. So time series analysis would be able to help us now analyze some type of trend in what we're doing there. And that's about it. I will see if I can. Thank you. Allow participants to unmute themselves. Unmute. Oh my goodness. Well, okay. Unmute yourself if you'd like to talk. I'm also going to, while you're doing that, I'm going to look at the questions that I have here. The first one here is from Daniel Valenzuela. It says, new data science student at Flatiron. What are some challenges with working on government data like the census? Man, I'm glad you asked. There's a lot. I think I spent the first 3 weeks. Ben remembers. Ben was one of my lecturers, but he remembers me trying to look at the census data. He's like, what is going on here? I was like, I don't know. But specific challenges, I think the government has a lot of links and a lot of stuff. They just put a lot of stuff out there. So the biggest challenge was, I mean, for me, was navigating all that stuff. I've already navigated it. So if you, Daniel, if you do want to get census data, let's not, reinvent the wheel. If you need help, just reach out to me, because that was a pain in the ass in French, or excuse my French, but whatever. But there's APIs in Python for accessing the census data, which I figured out after I created my own calls. And you just, it's a lot. So deciding what you're going to use, you need to know what you're looking for going in before you just go in. It's a lot of, there's so much out there. So you need to know what you're looking for, and then you have to read the documentation. I tried to read the documentation, but it's, as you can imagine, you open it and the taskbar or the trail bar is like half an inch, and can't read everything. But if I had read the documentation, then I would have realized that New Mexico and Virginia were excluded from that original data set rather than celebrating success. But do hit me up afterward if you're looking to analyze some census data. I had to let my sister go. Sorry for anyone who posted questions, but it's my sister, so.
Yeah, I actually wanted to ask the first question as your sister, but I'll ask the second one.
I didn't have the screens over, so.
But I was curious, was there anything about your analysis that surprised you? I mean, I assume you had a lot of assumptions about what you would find going in. What surprised you the most, or what did your data reveal that you would have thought would have come out another way before looking at the data?
That's a great question. I think part of me just wanted to see broadband and device access at the top as the most important feature, and be like, see, I told you guys, we need to get those people some internet, get them some iPods, and let's get, sorry, I'm aging myself by saying iPads, and let's get them started working. So I think I went in there with presumptions, and that obviously impacted what I got out, but I think I was surprised. I mean, the biggest factor was poverty ratio, and I kind of knew that it would impact the model, but I didn't expect it by that much. And relative to things like household income and people who have bachelor's degree, like I can go back to the slide, but it was just so far outweighed that it's like, what was the, I mean, obviously you can try and solve broadband, you can try and solve device access, and that's an easy thing to do. You buy more devices, or you tell the Comcast to keep building, but the poverty ratio, that being that disproportionate, it's like, if you're gonna focus 13 billion on education tech, which is what Congress has done in the CARES Act, it's like, how much are you focusing on poverty, right? Because that's the biggest thing. And so you can mitigate some of those things, and some of them are easier and they're quicker wins, but like, if you're not addressing that bigger issue, you're really missing out. So that surprised me. It also surprised me at the end too, that device access wasn't as important as broadband access. I don't know why I was surprised. I guess that's kind of makes sense. But and then as I continued going, this one small thing that I noticed was that there was, and I can look into it more and talk about it more offline, but there's a way of looking at the data that showed that potentially having too many devices might decrease assessment performance. So that's something I had to look into more. But yeah, those are definitely things that surprised me. John Labossiere, I'm not familiar with census taking measures from a high elevation. Filled out mine from the internet. The data we gather from this US Census also have blind spots in the areas you've discussed that suffer from the broadband gap. If so, does that affect your conclusion? Just gonna read it again, sorry. Data we gather from the US Census have blind spots in the areas. Yeah, I mean, I'm sure you've all been hearing about how the deadline of the census going back and forth. a lot of times it's just hard to access people, right? If somebody can't get out to somebody, people in rural areas aren't going to have, they're not going to have broadband. They're not going to have as good access to internet, and they're not going to have as good access to things like television, which will give them the information to call in if you need to. And it's just harder to access. So yeah, I think that's the biggest spot, I think, in the 2020 census, having, people having to get out to those places. Obviously, the places that need to benefit most from things like the census are going to be the hardest to access. And that's, that's inequalities, the essence of inequality, I guess. So that was definitely difficult. And yeah, as for how it affects my conclusion, I think, I think I went in here saying, like I said with Endo's question, let's get those people more devices and let's get this internet out there. And it's like, that's just not enough. So yeah. Next question, anonymous. I would expect that poverty would lead to decreased access to broadband devices. Is it possible that poverty is already taking into account the effects of intermittent and lack of access to tech in your model? I think that's definitely possible and probable. The poverty ratio it's a combination of things that the U.S. Census, and if anyone has studied the census more, please feel free to speak up about it. But I actually included that variable only because it was, when I was accessing the census API, it was easiest to access, if that's that's the honest question, the honest answer. I didn't expect it to be that impactful, but yeah, it doesn't necessarily take into account that, not directly at least, that access to devices or broadband, but it does take into account things like income and I forget what else it took into account, but things that will all be tangential to their ability to either access, broadband, right? If anyone lives in a rural area, they're, compared to like New York City, income is going to be slightly lower. Your access, things like that are just going to be generally lower. So yeah, I think it definitely includes that, but it's just hard to separate out, and that's why we looked at those feature importances to see exactly why or how much each feature was important in that model. Nick Emituzzi, what software language did I use for analysis, acquisition, cleaning, and modeling? Python. Python 3.8. It was basically the easiest. I mean, that's what we were trained on in Flatiron. Now Python is a monster on its own. There's packages upon packages, and it's always a trade-off between learning quickly a new package that will do what you need to faster or more efficiently, or just doing it the manual way. I think Python is good in that if you master the basics, which would be easier if you weren't moving into your new apartment during protests on June 1st, then you can navigate your way through. New top questions. That's about it. Anyone else have questions, desires, comments?
Alex, I put something in the chat.
Oh yeah, let me get to the Zoom chat. This is where I slightly age myself, but oh my goodness, there we go. Lots of messages in the chat. Let me open this. There we go. Thank you, friends. Yeah. Jeff says he has College Board data. Yeah, so Jeff Carlson works at the College Board. I actually consulted him earlier on in the process in terms of just which features and how to look at it. So Jeff, please share.
Yeah, so when Alex initially reached out, we didn't have any data from this last year, but in the last week, we finally got some data back. So we sent direct to student 5,500 devices in about April in order to help them prepare and then take AP exams in May at home. They were reimagined at-home exams. But then we compared those students who got devices to similar students on a lot of the vectors that Alex described. I think we had about 18 different dimensions that we looked at them to compare similar students. And to your point, Alex, so students who got any assistance overall saw a percentage point gain of 8% on exam participation. So kids who got a device from us were 8 percentage points more likely to take an AP exam than kids who didn't get a device from us who were similar kids. if they got a hotspot, if they got a Wi-Fi hotspot that we partnered with T-Mobile to give, they were 10 percentage points more likely to participate. But your thing focused on outcomes, and we saw a bigger gain there too. So if a kid got a device from us, they saw a 2 percentage point gain, 2 to 3% for any device from us. But if they got, so like mostly Chromebooks that Amazon donated, but if they got a hotspot to give them Wi-Fi, they saw a 7.6 percentage point increase on outcomes. So they were more likely by 7.6% to get a score that would give them college savings. And so those 5,500 kids earned a potential of $5.6 million in tuition assistance from those AP credits. So we've found in our work that devices help a little bit, but the actual Wi-Fi or some kind of connectivity helps a lot more. So just wanted to show you, like, so that, and that your data was looking at census tract data from before. This is this was like literal May 2020 exam taking. So we see it happening post-COVID as well.
Is that your way of saying I'm hired, Jeff? Because that's also my.
I'm gonna have you come give. Yeah, you're gonna come give this presentation to my team that's looking at this. We're also trying to get T-Mobile to give more devices, so I'm gonna tell them this too.
Yeah, wonderful. My cousin Camille has a question. How do we close the gap given the limited accessibility to broadband, particularly since the U.S. is behind in math and science? Yeah, I mean, I didn't really do much international comparison because it's I guess the way the U.S. educates is, I mean, it varies state by state, and then even on a national scale, it's not the most consistent. So I don't know. That's my real answer. I don't know how. I mean, I've been reading a lot about it, and Google always suggests more and more articles to me, which takes way too much of my time. But a lot of people are coming up with more creative solutions to get broadband out into places that can't get it. And actually, the SpaceX thing, I mentioned it as like an offshoot, but it's actually kind of impressive. Basically, they're flying satellites lower in a low Earth orbit and hoping to just build a network, right? So that, and they've been beta testing it already, and it should become deliverable very soon to be like to the broader public in a lot of those areas that don't have access very quickly. So a lot of projects like that, but that one in particular look particularly promising. And yeah, definitely. I mean, I wish I had studied. Marisa told me to do this earlier on, but to look at 2 different models that analyzed math scores separately from reading and language arts scores. I was just trying to get through the end of the process, the end of the day, but I could go back and look at that. But yeah, it is interesting. I'm interested to see, without getting into too many rabbit holes, but interested to see how some of these projects pan out. Let's see what else we have. Cool. How do you include access to students with disabilities like learning and reading problems? That's a great question. That's my brother, Edward. That's your mom. Oh, that's okay. Sorry, my dad and my brother have the same name. So include access to students with disabilities and learning and reading problems. If I could go back, but basically, yeah, it's a tough one because and this is the nature of inequality, like I said before, any individual factor is compounded by any other factor, right? So if you already don't have access, if you already have any sort of deficiency, your likelihood that you're going to be more deficient is like increased exponentially. So I think it was the 4th or 5th most important feature in determining assessments was just learning disability, or I think it said disability. I shouldn't qualify. It said disability, so I'm not sure if it was learning or physical. I just kind of extrapolated it and just went. But even still, if you have a physical disability and that's going to impact your assessment outcome, obviously, I don't think it's unfair to also extrapolate that learning disabilities would have a similar impact. Yeah. Monica had a question.
I'll just say it out loud. I was starting to type my thoughts in the chat. Hi, everybody. Alex, this is fantastic. Thanks for highlighting a lot of the social determinants that I think affect how children learn. We've seen a lot of our patients coming in and kids who already have delays or kids who have autism are really struggling with the screen. So it's not even the access issue or having the broadband at home that is an issue for them, as well as just like parents being worried because they're like, we're not teachers. So no matter how many devices we have, how good our internet works, like they can't replace the teachers who are physically helping students in class in person. But this is excellent, excellent work. And I'm so glad that you really took the time to point out other things that are affecting how kids learn and not just access.
Thanks, Monica. Monica's my cousin. She's a doctor in New York. I get to brag about them because my family's all full of smart people. So cool. JP has a question. What variables would you want to include in a more current data sample? And how would you expect predictions to change during COVID? And who's potentially missing from the census sample? Yeah, 3 questions. I think in my exploratory data analysis part, I think the first question that anyone should ask, and I feel like a lot of people don't emphasize this one enough. I've been reading, well, for some background, I've been reading Algorithms of Oppression, which everyone should buy if you're even tangentially related to computer science. I also read a book called Race After Technology by Ruha Benjamin. And the subtitle is Algorithmic Tool or Tools of Abolitionist Tools for the New Jim Code. That's what it's called. So big, I mean, if you're starting to look at data at all, definitely start with those books, because what it looks at basically is just the idea that every time you look at data, you should ask what's missing, right? It's an interesting thing because like as soon as you go into census data, right, already you're excluding, even if you look at the 2020 census, if it ends tomorrow, I haven't been paying attention to the news on where we are exactly on this, but if it ends tomorrow, 14 million people could exclude. If it ends in a month, then maybe it's 12 million or 10 million or just 5 million, right? So just off the bat, just a lot of people that excluded, and a lot of people, don't answer the census because for fear of for immigration and things like that, it's very highly political. So that's the first. I guess that's the last question that you asked, JP. The second question was, how would you expect predictions to change during COVID? COVID was my impetus for studying this, because with all those blue dots, the amount of schools that are just going remote, by default, is wild to me. I mean, even Georgetown kids are not doing the best on staying on Zoom all day. So I can only imagine, right, if you're at home and your parents are either working from home on your internet already, or or out working essential worker jobs, right? The stress of trying to educate children or trying to be educated just gets exponentially worse. So I think that if I had looked, if somebody took an assessment, a similar assessment, and we did ran the same model, I think, or we fitted the same model, I should say, I think those 2 factors, broadband access and device access, would also they would just increase, because because if that's how your education is coming to you and you don't have access to it, then you're just falling behind. You're not even, so it's tough to say. You have to be able to take the assessment in order for it to tell how, in order for people to understand how you're performing. So if you can't take the assessment, it's not going to show up in the first place, to your point of who's missing. But even if you can take the assessment, it's just not going to be, I presume that it will just be significantly worse, and that those features will be significantly more important. And variables that I'd want to include in a more current data sample, everything. The great thing about Python data science is you really can include as many as you want, and there's ways of fixing and fine tuning everything. But I'd want to know more, I guess more granularly, about education levels specifically, about access to different types of resources, about geography. I didn't include geography. I think that's where I'd start. It's one of the biggest tells of a lot of these other variables that we looked at. Any other questions? Last chance, not last chance. You can hit me up on any of these links or whatever if you'd like to ask more questions. Thank you for your time. That was my not TED Talk. If anyone wants to chat, hit me up. I'm probably just gonna have a celebratory beer or two, maybe a glass of wine. But yeah, hit me up. I'm around to chat. Thank you all for coming. This has been great.